Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and US.
So let's start with a simple problem. This is ISI M.Stat 2024 problem number 2. So let's look into this problem. So this is ISI M.Stat 2024 problem number 2. So it asks that there A, B, and C are three distinct non-zero real numbers. Okay, where this expression is given. So this expression is a polynomial because you see x above and no x below. So it's a polynomial, not a rational polynomial. Like it's not a polynomial divided by a polynomial, it's a polynomial where A, B, C are constant. Okay, so for our clarity, let's take a screenshot of this. Good. We will go to the next page and we will just focus on this expression only so that our attention doesn't get diverted. Great. So it says that this is an expression of a polynomial expression. Okay. So it's asked that the question is asking that about for which expressions the number of values for which this expression is zero. Okay. So which is called in mathematical language the roots of the polynomials. So whenever you have a problem, let's first define it mathematically. That's the first step always. So this is fx. Okay. Now it's asked that how many x are there such that fx is equal to 0. How many such x are there? This is a question. So step number one, must have observed that what kind of function it is. Do you know? So step number one, that do you know any kind of similar functional form? Yes, we know it's a polynomial, right? Can you describe the polynomial a bit more? Yes, it's a 2-degree polynomial because there are 2x here and 1x here. So it's a 2-degree polynomial, 2 degree. So when this first information came to your mind, after looking into this problem, some information came into your mind, right? So this information came into your mind. So next natural question is that using this information, can you get any update about this problem, about what is the required solution? Can you get any update from this? What can you infer from the about x, about this statement from the statement number one? Anyone? From this information that it's a second degree polynomial, fx is a second degree polynomial, what information about this statement, how many x such that fx is equal to 0 is there from this one, from this information one? So you can say that means you're going the right direction because you have found out something about the RTF. So you're going the right direction. This is how you know that you're in the right direction. So that means you know the number of roots. Let's call the roots, what we call this the roots, is less than equal to 2. Okay, so now we want more. We know at most 2. So here it's asked about exactly how many values. So we need to be very precise. This means that we have to use more information about the function fx, right? So therefore we look into the expression of fx. So if you put a, b, and c, you will see that the value of fx is 0. That's super. And what information is given on a and b and c? A and b and c are distinct. So what does this second information tell you about fx or this RTF? So therefore this says that number of roots is 3. Or let's write like this. Okay, so it says number of roots is 3 and number 1 says number of roots is less than equal to 2. So it's a contradiction, right? It can never happen. So what is the issue? The issue is that if you expand this, you will probably find out that all the terms are cancelling out. And it turns out that you will probably find out. And it turns out that the expression on the left hand side is nothing but fx is equal to 0. So this is a result that if a polynomial has n roots, but you're finding more than n roots, that means the polynomial is 0, right? You can easily show that. That means the polynomial is 0. You can easily prove that. It's very simple to prove. Okay. That's the only that therefore it means if the function is 0, if the polynomial is 0, then it has infinitely many solutions. Because whatever you put in, the output will be 0. So therefore infinitely many roots. So therefore this is the one. The only statement that we used is that a polynomial of degree n fx has more than n roots, then fx is equal to 0. Do you want me to prove this fact? or will you accept this fact? If you accept this fact, then we can move on to the next problem. If you want to prove this fact, I will prove it in front of you. So we use this. It always says that the coefficient in front of the largest, I mean x to the power in front, the coefficient in front of this is always non-zero. It always says that. If it's zero, then it will never happen. And that's exactly the case. When it's zero in all the coefficients, it will have infinitely many roots. Okay. So if let's say a polynomial has degree n, let's say, okay, let me show it to you. Let's say a polynomial of degree n, by the fundamental theorem of algebra, you know that f of x is equal to, has n roots. You know that. Let's say you know that. What will happen is that sine times some a. Okay. Now what will happen is that let's say it has one and another one more root, you find it out. That means f of an plus 1 will be equal to a times an minus an plus 1 minus 1 dot 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 an plus 1 minus an. This should also be 0. Now you know that an plus 1 is distinct from a1 to an, right? Because it's another extra root. So all of these are non-zero. Only this is extra part left. And that should be therefore equal to 0. Hence fx should be 0. No, that's the basic idea. Did you understand, all of you? So a polynomial of degree n can only have at most n roots.
If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.